Okay, first off, I want to go ahead and show you how to solve the problems on this page. It starts out with find the zeros of each function by factoring. Zeros means the places where your graph crosses the x-axis, like for instance here. That means the same thing as the solutions or the x-intercepts. So the x-intercepts are the places we're looking for when we're solving a quadratic. And any point on the x-axis has a y value of 0. So when we're being asked to find the zeros, we're being asked when y is equal to 0, what is x, which is the same thing as the x-intercepts. So the first thing we always do is set it equal to 0. Now the next step is I factor. Okay, now if you had any trouble factoring this, I went ahead and did it over here on another sheet of paper. So to get from this step to this step, this is what I did down here. I said 1 times 3 is 3. I need two numbers that multiply to give me that and add to give me the -4 that comes from right here. The numbers I had were -3 and -1. So I broke up -4 into -3 and -1. Now I have 4 terms. I group them together in pairs with parentheses. Notice that I put this negative here and a plus here because I always want to have a plus between my parentheses. Next, I take the greatest common factor out of this first set. The greatest common factor of x squared minus 3x is x. When I take it out, I'm left with x minus 3. So when I go over to this other pair, I want to take out whatever I need to take out to leave x minus 3 inside the parentheses, because these two have to match, these two sets of parentheses right here. So that's a -1. If I take a -1 out, I'm left with -1 times x and -1 times -3 to give me 3. So now they match. And your final step in factoring this is you take whatever was in parentheses already and put it in parentheses. And then everything that was outside the parentheses, x minus 1, goes in the other set of parentheses. This is now factored. After the factoring, you have to take each factor and set it equal to 0. So I said x minus 3 equals 0. And I solve that and I get x is 3. And over here I said x minus 1 equals 0, and I solve that and get x equals 1. Now on the next one, first I'm going to set it equal to 0, as you can see I did there. This one's a little bit harder, but we're just going to use grouping like we did on the last one. So I'm going to take 2x squared plus x minus 6. My first step is I'm going to multiply 2 times -6 and get -12. That means I need two numbers that multiply to give me -12 and add to give me 1. The 1 comes from right here. Those two numbers are going to be 4 and -3. So I will break up my middle term into two terms. Now it's going to be 4x plus -3x. Again, I go ahead and put the negative here and put a plus in the middle so that when I group, I have two sets of parentheses with a plus between them. Now I'm going to take the greatest common factor out of the first pair, and that's 2x. And that leaves me with x plus 2. So I need to take out whatever comes out that would leave me with x plus 2 here. And that would be a -3. If I take out a -3, I'm left with x plus 2 because -3 times x is -3x, and -3 times 2 is -6. Now I'm ready to write the factored form. One set of parentheses is the part that's already in parentheses. The other set of parentheses comes from everything outside the parentheses. So 2x plus -3, or 2x minus 3. So that's what I have here when I factor this. 2x minus 3 times x plus 2. Order you write it in doesn't really matter there. So I'm setting each one of these equal to 0 and solving. When I set 2x minus 3 equal to 0, I'm going to have to add 3 to both sides. That gives me 2x equals 3, and then divide by 2. So x equals 3 halves, or 3 over 2. Over here, x plus 2 equals 0. Subtract 2 from both sides, and x equals negative 2. All right, last one on the first row. Again, you set it equal to 0. I could do this one the same way I did the first two. Or because there's nothing in front of x squared, I could take the shortcut. And that is find two numbers that multiply to give me this, which is the same thing as 1 times this. 1 times negative 18 is negative 18. And add to give me this. I know that seems like grouping so far. Those two numbers would be positive 9 and negative 2. The difference is when it's like this, where the leading coefficient is 1, the number out in front of x squared, I'm really done at that point. I can just write those two numbers with x in parentheses. So now I'm ready to solve. X plus 9 equals 0 means x will equal negative 9. X minus 2 equals 0 means x will equal 2. Okay, that's solving by factoring, finding the zeros by factoring. And there's lots more factoring you could do, a lot of different types of factoring you could do. So you may want to go back and look at section 16.1 in your textbook. There are a lot of different types of factoring you could have to do before you solve it. The only part that's new to us is the solving part, where it's equal to 0, and then we set each factor equal to 0 to solve. Now everything else on here has to do with completing the square. These first two, we did some like these in the book. They're really not asking you to go anywhere near as far as completely doing everything. So it's really important to understand what's being asked here. This says complete the square for each expression. Notice expression, this is not an equation. We can't solve these because there's no equal sign. There's nothing to solve. There's nothing equals. You can only solve something that's an equation. All it's asking me to do is to do the part that helps me decide what to put in the blank. So I take half of negative 6 and square it. That's negative 6 divided by 2 is negative 3. Squared is 9. Do that part and then write what this is going to be factored. In other words, write the part in parentheses. That's x minus 3 squared. Remember that half of negative 6 squared gives me this, and just the plain old half of negative 6 gives me this. So over here, I'm going to take half of 10, which gives me 5, and square it. Half of 10 was 5, and that's what this is as a binomial squared. If you were to multiply this out like FOIL, you would get this right up here. These two things are equal. Number 6 and 7, write each function in vertex form and identify its vertex. So on these, we really do have to go through the completing the square. Okay, you have to go through with completing the square to get it to vertex form. So I'm going to go ahead and use this note sheet we came up with. Number 6 is x squared minus 10x plus 3. And this note sheet can help you anytime you're doing one of these. You can just follow along on this sheet. So starting in standard form, and we really need to have it equal to 0. Move the constant term to the other side. In this case, the constant term is positive 3. I move it by subtracting 3 from both sides. This is where I put the blanks. Now we come to the part that we were just doing on the other problems, where we get to decide what goes in this blank. Half of b is half of negative 10. That's negative 5. Squared is 25. Remember that what goes in here is always going to be positive because you got it by squaring. Now whatever we got when we took half of b goes here. And that means it has the same exact sign as b. If b is negative, this will be negative. Negative 3 plus 25 is 22. Okay, so we've already done the factoring the left side. We're already done. We have completed the square here. All that's left is to write it in vertex form. So we're coming to this part. For this part, we do not take the square root. The square root happens over here. That's part of solving. So if you were asked to solve, you go ahead and take the square root. If you are not asked to solve, if you're asked for vertex form, stop here, move everything over to one side like it would be equal to 0, but we're not going to put it equal to 0. We're going to put y equals out front, and we're done. That's in vertex form. Now the vertex is the opposite of this number and the same as this number. There's my vertex. And the axis of symmetry would be x equals 5. Don't forget the x equals. That was number 6. Number 7. X squared minus 8x plus 5. Okay, I'm going to go ahead and put it in standard form right here. So instead of f of x, I put it in standard form. First step is to move that 5. So I'm going to subtract it from both sides. Remember, the goal here is to have the x's all together on one side and then your plain numbers on the other side. Usually you put the x's on the left. Anything with x goes on the left. Anything with a number goes on the right. That's just at the start of the problem. Now we're going to fill in our blanks by taking half of this. Again, it's negative. So when I take half of it, I get negative 4. But when I square that, I get positive 16. So half of negative 8 is negative 4, but square it, and you get a positive. Again, though, half of negative 8 is negative 4. So this is where we see the negative follow the negative 8. If it's negative here, it's going to be negative here. Negative 5 plus 16 is positive 11. Again, we were not asked to solve it. If I was asked to solve it, I would come over here and take the square root of both sides. I wasn't asked to solve it. I was asked to put it in vertex form. Vertex form says move everything back onto the left together. Really, you're just moving the number. So you move the number over, and it's minus because we subtract it from both sides to move something. If it was a negative over here, we would have to add it to both sides to move it. And then I'm going to put y equals out front. My vertex on this one is 4, negative 11. This is the opposite sign. The y value is not. And the axis of symmetry is x equals 4. Okay, just to practice, what if they hadn't said put it in vertex form? What if they had said solve it? And then I would take this part right here, x minus 4 squared equals 11. And I would take the square root of both sides. This is where the plus or minus goes. As soon as you put the radical on that number, you're going to do plus or minus. On this side, the radical and the parentheses with the squared, those two things basically cancel each other out. Technically, that's not the right term, but that's what's happening. The radical sort of lifts the squaring off. Those two things are opposites. And over here, I still have this. When I move the 4, adding it to both sides, it slides up here in front of the plus or minus that stays with the radical. This one is simplified as far as I can take it. I cannot take it any farther than that. So my answer is 4 plus or minus the square root of 11. That's really two answers. 4 plus the square root of 11 and 4 minus the square root of 11. Let's go ahead and look on the one we were doing for number 6. Same idea. If I solved it now, I would take the square root of both sides and get x minus 5 equals plus or minus square root of 22. Add the 5 to both sides and get 5 plus or minus square root of 22 and stop. The reason I'm stopping here is because there's not a perfect square that goes into square root of 22. If it had been, let's say it had been 5 plus or minus square root of 20 instead. Well, I could simplify that a little bit more because square root of 20 is square root of 4 times square root of 5, and square root of 4 is a 2. So then I would have 5 plus or minus 2 times the square root of 5. So if you can simplify it, you should, but this one I cannot simplify, so I leave it alone. Don't forget, if you get just plain numbers here, if you get something like 5 plus or minus 2, you can simplify that, so you should. You should do 5 plus 2, which is 7, and 5 minus 2, which is 3, and those are my two answers, x equals 7 and x equals 3. Again, that's sort of just an imaginary case. Here, that doesn't happen. Hope that's helpful. A couple of other reminders, things you might want to think about. One thing we did that is not on this review is if you are given two roots, if you're told, hey, this parabola has roots at -2 and 5, then that means it has factors at x plus 2, opposite sign, and x minus 5, opposite sign. If I wanted to write an equation for it, then I would FOIL this, simplify it, and this is what I get. So in other words, this is an example of what I would do if they say, here is, you have a parabola that has roots at -2 and 5. Write one possible equation for it, or write an equation for it. This is what I would do. So another example, let's say you're told you have a parabola at, a parabola with roots at 1 and 4. Or you might not be told that way, you might see them on the graph. You might see that it goes through 1 and 4. Okay, and you're asked to write an equation for it. Well, if it has a root at 1, or a solution at 1, that means the factor that goes with that would be x minus 1. And if it has a solution at 4, the factor that goes with that is x minus 4. So I'm going to multiply those out. I get x squared minus 4x minus 1x plus 4. And I can simplify a little bit, so I do, and that would be my answer. Excuse me. So remember that what we're finding on all of these, we're finding the places where your parabola crosses the x-axis. Those are your roots, and they could be called roots, they can be called solutions, they can be called zeros, and they can be called x-intercepts, because that's what they are, is the x-intercepts, the places we cross the x-axis. Good luck tomorrow. Remember, you have a sub, so please be on time. See you Monday.